Hello everyone, myself Shilpa Shrike, studying at Sri Venkateshwara College of Engineering in CSE Cybersecurity branch. Today I am going to be discussing about the sound control and temperature control in buildings. Sound and temperature control in buildings. This presentation delves into the critical aspects of sound and temperature control within buildings, exploring principles, techniques, and sustainable solutions to enhance the overall well-being and productivity of occupants. The importance of sound and temperature. Enhanced productivity. Noise pollution can significantly disrupt concentration, leading to reduced productivity and increased stress. Effective sound control creates a peaceful and focused environment, fostering a more productive workforce. Improved comfort. Maintaining a comfortable indoor temperature is essential for occupant well-being. It can reduce the risk of health issues, increase comfort levels, and positively impact overall satisfaction with the building. Increase property value. Buildings with superior sound and temperature control features are generally more desirable, resulting in higher property values. This translates to better returns on investment for building owners. Principles of sound transmission and absorption. Sound transmission, the process by which sound energy travels through a medium such as air or solid materials, is known as sound transmission. This occurs when sound waves encounter an obstacle and vibrate the material. Sound absorption, the process by which materials reduce the intensity of sound waves by converting sound energy into heat, is known as sound absorption. The effectiveness of absorption depends on the material's characteristics such as density and porosity. Sound reflection. When sound waves encounter a hard surface, they are reflected back into the space, contributing to noise reverberation. This can create undesirable echoes and make spaces feel noisy. Airborne sound transmission through walls and floors. Sound path. Airborne sound, such as voices or music, travels through the air and can vibrate building materials. This vibration can then transmit sound through walls and floors, creating noise in adjacent rooms. Mass and density. Heavier and denser materials such as concrete or brick are more effective at blocking airborne sound transmission. This is because they resist vibration and absorb energy, sound energy. Air gaps and insulation. Creating air gaps between building materials and using sound absorbing insulation can significantly reduce sound transmission. These materials absorb sound energy and prevent it from passing. Impact sound transmission and methods of isolation. Impact noise. Sound generated by impact, such as footsteps, furniture movement, or dropped objects, travels through structural elements like floors and ceilings and can be heard in other areas. Resilient channels. These specialized metal strips are used to decouple the drywall from the framing, effectively reducing impact sound transmission by creating a resilient barrier that absorbs vibrations. Flooring choices. Carpet, especially with an underlayment, provides excellent sound absorption, reducing impact noise. Hard flooring materials like tile often require additional soundproofing measures. Temperature, comfort, and factors affecting indoor temperature. Solar radiation, air movement, humidity, personal factors. Solar radiation. Sunlight can significantly affect indoor temperatures. Strategically designed shading systems and window glazing can minimize heat gain from direct sunlight. Air movement. Air movement such as drafts or wind can influence thermal comfort by creating a cooling effect or increasing heat loss. Ventilation systems should be designed to minimize drafts. Humidity. Humidity levels play a significant role in thermal comfort. High humidity makes it hard for sweat to evaporate, leading to a feeling of discomfort. Air conditioning systems can help regulate humidity. Personal factors. Individual preferences, clothing choices, and activity levels can also influence thermal comfort. Providing options for temperature adjustment can accommodate individual needs. Insulation materials and their role in temperature regulation. heat transfer, fiberglass insulation, spray foam insulation, cellulose insulation. Heat transfer. Heat transfer occurs through conduction, convection, and radiation. Insulation materials are designed to resist these processes, reducing heat loss in winter and heat gain in summer. Fiberglass insulation, a common and cost-effective insulation material that traps air within its fibers, reducing heat transfer through conduction and convection. Spray foam insulation, an effective air sealing insulation that fills gaps and cavities, reducing air infiltration and heat transfer, providing a high-performing thermal barrier. Cellulose insulation, a sustainable insulation made from recycled paper products, providing good thermal resistance and sound absorption, contributing to a quieter and more comfortable environment. Ventilation and air conditioning systems for temperature control. Ventilation. Ventilation systems provide fresh air and remove stale air, helping to regulate indoor temperature and humidity. They also play a crucial role in reducing indoor air pollutants. Air conditioning. Air conditioning systems regulate indoor temperature by cooling the air using refrigerants. They can also dehumidify the air, improving thermal comfort and reducing mold growth. Energy efficiency. Modern air conditioning and ventilation systems are designed to operate effectively or efficiently, minimizing energy consumption and reducing environmental impact. This is crucial for sustainability in building. Energy efficient design strategies for sound and temperature control. Passive design, high performance windows, green roofs. Passive design, using natural elements such as sunlight and ventilation to regulate temperature, minimizing reliance on mechanical systems, reducing energy consumption and environmental impact. High performance windows, energy efficient windows with low emissivity coating reduce heat gain from sunlight and heat loss in winter, enhancing thermal comfort and saving energy. Green roofs, vegetated roof surfaces provide thermal insulation, reducing heat gain in summer and heat loss in winter. They also improve rainwater management and enhance aesthetics. Sustainable building practices and their impact on indoor environments. Sustainable building practices prioritize energy efficiency, resource conservation, and occupant health. These principles of indoor environments by reducing environmental impact and creating healthier and more productive spaces. Thank you.